we're going to look at trickier examples on word questions that I might have to use logs for. So again, I'm just going to say that I normally read it a couple of times, maybe even 3 times, and the first time I'm looking for just general information. So a certain type of bacteria is growing exponentially, where y is equal to a e to the power of b times t is the number of bacteria present after t hours, and b is the growth constant. Under certain conditions, bacteria doubles in population every 6.5 hours. If at the end of the experiment, under these conditions, there are 100 bacteria present, find the growth constant. That's part 1. They want me to find growth constant B, and part 2, they want me to see how many bacteria will be present after 2 days. Now, so I'm gathering that there's bacteria that are growing at a certain rate. I'm going to have to use this formula. Time is in hours, and they want me to find the growth constant B. The bacteria doubles in population every 6.5 hours. So that's just a general idea of what's going on. The next time I look, I'm going to underline my formula. That's very important. And anything else that stands out. So the bacteria doubles every 6.5 hours. And if at the start there is 100 bacteria present, you know, they're all the numbers that I need to pull out and the formulas that I need to pull out of the question. What can be very important here is that at the start of the experiment, now that might not sound like much information or important information, but I could often get stuck in this question if I don't realise that that is actually a number as well. It's saying the time is 0. So I need to watch out for that in these type of questions. It could actually be the key to me figuring out this question. So I'm going to write down my formula. Y is equal to a e to the power of bt. And what I know is that at time is 0, that from the question there is 100 bacteria present at the start. So I know that y is equal to 100. And they want me to figure out, you know, A and eventually B. But I'm not sure I'll be able to figure out B if I don't at least try and work out A. So I have 100, filling in my formula, is equal to A e to the power of B times T. Anything by 0 is 0. So I have 100 is equal to A e to the power of 0. Anything to the power of 0 is 1. Therefore, A is 100. Now that I know that, perhaps I can go back to the question, look for more information and try and figure out what B is. When I go back to the question, they tell me that under certain conditions, the bacteria doubles in population every 6.5 hours. So now time is 6.5. And it doubles. So if it originally was 100, then if it was 6.5 hours later, it's going to be 200. So y is now 200 is equal to A, I now know, e to the power of b, I don't know, and 6.5. I can bring the 100 over, it becomes division, so 200 divided by 100 is just 2, is equal to e to the power of b times 6.5. And I notice that I have a missing power, that means logs. I can go to my log tables and use this for changing it into logs. So I have the base number is e, so I could write it as ln, or log in the base e, of 2 is equal to my power. You can throw this into your calculator. So we have log in the base e, or ln, of 2 is equal to that. And I'm going to divide that by 6.5 in order to get what b is. Now, unless they ask me to round off, I'm going to take all that down. So we have 0.1066380.278 is equal to B. And the second part of this, how many bacteria will be present after 2 days? Well, now that I have A, I have B, I should be easily enough able to fill in my formula. And I could store that button in my calculator if I wanted to, because it's quite a long number and I don't want to round off unless they told me to, which they didn't in the question. So I have y is equal to A E B T, and I want to know what y is when A is 100, E to the power of B, I have written up here 1.066380278 times the time, and it says how many bacteria are present after 2 days, so that's times 48. And when you work that out, you end up with approximately 16734 bacteria. So when you're doing one of these questions, you need to read the question carefully, skim through it the first time, then try and pull out your formulas, any numbers that are important. Remember, watch for that number, even though it doesn't look like it, maybe unless you have practiced this, the number that it says the time is 0. So in this question, it said if at the start of the experiment, that's the key to going that time is 0. And I need to watch out for that in the question. So pull out all your formulas and numbers. And then the third time, go through it one more time. And then start writing down your formula, filling it in, trying to work out, what they've asked for and any other part of the equation that you need, even if they don't ask for it.